thank you for joining our second webinar in this series of 4. Today's session will be led by Marcus Duffy, who's our geoscience team lead here in Europe and based in our Aberdeen office. Marcus today is going to show you an introduction into the growth of our petrophysics workflows inside tNavigator. Marcus, if you can just switch to the next slide, thanks. So as with all of our webinars, everyone will be automatically muted. So if you do have any questions, you can put them into the chat box and we have some time for Q&A at the end. And we're recording the session, so we'll put that on our YouTube channel later on today as well. Okay, thank you very much, Marcus. It's over to you.
Okay, thank you, everyone. Thank you for joining today. I'm calling in from a very snowy Aberdeen, so just made it into the office today. It's quite a lot of snowfall last night, so but very glad to be here, and hopefully can give you a bit of information onto how tNavigator is growing into the petrophysics space. Now, for those of you who are maybe not aware or haven't maybe come across us in this space before, well, let me just give you a bit of an introduction to tNavigator. So we're a fully integrated reservoir modeling platform designed to take you seamlessly from the subsurface to the surface within one single environment, tNavigator. It brings together geological modeling, so that's what I do as a geologist, all the way through to dynamic and reservoir simulation, uncertainty quantification, statistical analysis, and network or facility modeling. So everything that's on the surface, we can model this in one space. And then, of course, move through onto history matching, doing lots of ensemble modeling and optimization on these models. Now, integrating petrophysics is essential in any subsurface modeling. High quality petrophysical inputs improve the reliability of our static models. It enhances our dynamic predictions, and it strengthens the uncertainty assessments, and ultimately enables more confident decision making. By incorporating rigorous petrophysical interpretation directly into tNav workflow, we can ensure that the reservoir models are built on robust, like physically meaningful rock fluid properties. So you see here on this kind of like schematic idea of what we do within tNav. We start from the geology and geophysics and move all the way through to our dynamic modeling, our network modeling, and our surface modeling. But where does petrophysics fit into this? It's an area of growth for us, and it's something I've started to look into a little bit more this year, and actually realized we have a lot more functionality than I might have thought initially. So on the top right there, you can see the tNavigator kind of home start screen with all of the different domains that we have access to in one software. I'm going to be looking at the geology designer part of that. So that's our G&G static modeling part of tNavigator. And note that all of these, whether you're an engineer, a geophysicist, or a geologist petrophysicist, you're working in the exact same interface with the exact same workflow, which allows you to seamlessly move between these domains. We're celebrating 20 years this year. We started, and maybe you know us initially as a fast simulator, but over these 20 years, we've grown into all of the spaces, all of the different domains that make up asset modeling. And now we're excited to kind of show you some of the functionality we have in this petrophysics space. Today, the topic of discussions will look at a brief overview of the abilities we have within tNav for correlation and mapping, some of the well calculations we have and what we hope to add in the near future. Integrating both borehole and core images. This is fundamental for petrophysics, not just have our well log data, but also be able to look at our borehole and core data within the same interface. I touch on geomechanics, and that's a whole nother talk that we'd be delighted to do in the future, and get in contact if any of these topics you'd be interested in a bit more detail. And then I'm going to touch on a slight Python example just to show you this inbuilt Python capabilities that we have within tNav, the power and strength that this adds, and the flexibility that it brings to your workflows. And even if you're not a Python expert, I'll show you how this can still be very useful. And then finally, integration. It wouldn't be tNav if we didn't bring a conclusion to integration, how all of this kind of comes together. So in a standard geology training, or when I'm talking to a user about what we do in the G&G space, I would typically cover these 4 spaces: geophysics, our seismic interpretation, work with attributes, our correlation, how we look at all of our wells and we correlate these across our field, and then how we build this static model and how we interpolate these properties before we move on to volumetric sensitivity uncertainty studies. The focus of today's talk is going to be predominantly looking at this one part, correlation, and that's where I'll start. So here's just a very quick overview of the types of tools, the types of workflows you might want to start doing within tNavigator. And this starts from the top left. I'll move around in a clockwise manner from well correlation. So you see in the top left there an example of viewing all of your well log datas. You can put any kind of attribute or property in the background there to see how this fits in the interwell space. We can view our data in crossplots and histograms. We've got a range of petrophysical calculations. I'll show you the kind of the library that we're building up at the moment. And then of course we want to map this data out. And you see some of the advanced tools we have there for making some dip maps, or potentially you need to you take some paper copies of a report, you can bring these into tNav, digitize these contours and produce horizons and start using these to build maps and display petrophysical properties onto. And then of course, more advanced tools like geosteering, borehole, image interpretation. Now, if we start with that correlation, we brought data into tNav. Let's have a quick look at how this might look. So here you can see our well section window with a bunch of different logs already displayed: gamma ray, porosity, our density, and our fascias interpretation. You can very quickly situate these windows and have a multi-tab display. You see our histograms, our crossplots, and then we can just with a couple of clicks update these templates across both the crossplots and our well section windows within a couple of clicks. You can double click on any window to make it full screen, so you're making full use of all this good data. Here we can see interactive methods for adding our well tops, or our markers as we call them in tNav. You can easily just type in values, drag these around, and then all of our tools are easily accessible on the right hand side there, like our ghost curve, and we can expand these both horizontally and vertically just with a control and scroll on our bar, just so we can use that to compare logs across our different wells very simply. We can look at our calculations and a range of tools that we have to edit these, and a petrophysical library. We might want to quickly calculate a new shale volume by gamma ray. I'll look at the methodologies in a second as we have, but we can calculate this and then view the result within tNav very quickly. Now go on to add the rest of our well tops here that have already been calculated. We can look at our zonations, highlighting our reservoir interval here. But not only do we want to understand our logs in a vertical sense, but we also want to understand what's happening laterally. So we can jump back out of this and we can create some new windows to start looking at map views and looking at averages across these wells for that reservoir interval that we just identified. So here are our wells. We've calculated an average porosity for that section, which we've identified as our reservoir of our unit of interest, and we go ahead to the mapping calculations, so our universal interpolation. There's a few inputs you have to put in here, including your interpolation type. In this case, we went for convergent first. We can calculate a first kind of map to get an idea. We can see our distributions on those templates there. And again, just as we saw for our well sections, very quick, just to quickly change those templates, update to some more scientific plots, add our contours. Now we're going to go ahead and just rerun this calculation again and try a few different interpolation methods. And this is useful just to kind of see how these might have an impact on how the data is correlated across the map. In that multi-tab display again, we can view all of these together. Note that you can sync your cursor in red there. You hold shift to get this tooltip of information, and then we can quickly edit and our templates interactively to more easily see kind of patterns in the data. And you can do this for maps, properties, seismic attributes, very quickly and easy to play with. Now we've picked the one we like best. In this case, we've gone for minimum curvature, and we're moving forward with that map. And now you can see the ability just to tick on some bubble maps where we've got these fascias that have also been calculated for that reservoir interval and display those on as well. Now, that well section we had earlier, we can choose an interval to display and then also choose to bring this up in our window. So lots of ways in which we can take that good information from our well log correlation panel and add this in multi-tab displays to really get the most of our data. Now on the left here, if we want to look at what calculations we have available in the petrophysical space, there's a range of tools for log creation, creating classifier logs to calculate fascias based on a bunch of different log inputs, transformations, so if we want to normalize data, if we want to mute data, remove anomalies, a range of tools in there across transformations. And then we look at calculations. You can see the calculations have already been added into the software for pressure conversions, calculating rock quality indexes, doing linear regressions. And then at the bottom there, we see our petrophysics and our geomechanics. So I'm not opening up the geomechanics, but we will come on to that because it would go off the screen. But the petrophysics there, you can see the calculations of the library we're starting to build up. Now, of course, at the top there, we have the calculator also. So for any calculation that is not already inbuilt into the tNav interface, you could just type it in a kind of calculator statement and apply it. So looking at some of these petrophysical calculations in a bit more detail, here's an example of looking at our shale volume by gamma ray. So I'll just go through these briefly. So these are embedded log calculations. We can take our gamma ray index, which we can calculate and normalize for within tNav. And then we can select a range of these different methods, and they're going to be useful depending on what the geology is, what the age is, and what the mineralogy is of the V shale and the mineralogy you're trying to calculate. So you can see we can also display this in 3D. We can then view the results in crossplots and histograms, and so there's a large range that we can compare there. So if this is an example now where we're just comparing those V shale calculations across our crossplots, and you can see the ranges that we get there depending on what method you chose, but we can also display these in a histogram window as well and start to compare these data. So if you look on the left there, you can see how we select our logs. We can pick an X or Y, and then we can also color these by a palette color, which would be the third box. When we look at other petrophysical calculations, just to briefly touch on these, you can see we've got a range for porosity, so calculating porosity from sonic or from density, our permeability calculations, including Wiley-Rose, Coates, and Dumanoir, and then water saturation, a range of kind of standard water saturation calculations, and these are being added to depending on client interest. And so if you do have feedback for us, we're always delighted to add this. And for those of you who have used tNav for a while, you know how quickly the development makes it through with 4 releases a year. Hopefully everyone's pleasantly surprised how quickly the software and the equations they demand makes its way through to the software. So thanks to our great development team for being so quick and agile with that. Now, when we're looking at analyzing our data and understanding it, of course, visualizing it and how we visualize this and how easy it feels is of great importance. We've put a lot of work over the last few years into our interface and how seamlessly this feels for the user. And if we just go through a few examples of maybe looking at this data, we see the cross plots in the top left there. And then we have this lovely feature where we can just draw an area onto these cross plots, and we can link, clicking that little blue link button there, and allow us to highlight this data within the well section window. From here, with just a couple of clicks, we can turn this into a Boolean log, a 1-0 log, and create a brand new log just with a couple of clicks to identify high net zones, high porosity, high permeability zones, and quickly assess our data in multiple windows. Moving to the right there, you can see these heat density maps of crossplots. So not only are you looking at the relationship of the data, but you can also understand where the density of the data sits as well. Statistics can be viewed for any log simply just by right-clicking on an object and looking at statistics for one well, for all the wells, and you get a very nice quick summary. And these tables are used for quick summaries where you can get a quick histogram and look at the minimum, maximums, the standard deviations. Of course, if you want to go into more detail, you can create statistical tables where we look at the log and get a lot more information. We can also view histograms and color these based on different data sets. And if we look at the bottom right there, this is looking at an example of our dynamic data and our saturation in the bottom left, and then viewing our permeability on the right there. And as we run that simulation, we can also update this and see how that crossplot changes with time. So the benefit of being able to do your petrophysics in Jolly Designer and carrying this all the way through and comparing the initial petrophysics through to the simulated and dynamic petrophysics is great strength. And in the bottom left there, we have our stratigraphic table. So not only do we want to analyze and assess the data, but using these tools is a communication opener. If we can highlight the units, the formations, and make this data look nice, it's much easier when we're talking to different teams and different domains to explain which units we're targeting. So when we look at petrophysics, we also want to bring in core. There's lots of good information there. Core can easily be brought into tNav and be viewed against our log data. And here's just an example of some demo core logs that we brought in with a map to show how easy it is to edit these, interactive tools to quickly move these around, change the depth, drag, stretch, and squeeze if necessary. Of course, we've got this multi-tab display again with our maps and horizontal core view, so we can look in a bit more detail. We've got find well functionality, so if you've got hundreds of wells, you can quickly jump between wells in map view with that red cursor to jump between hundreds of different wells and find them. And then with any tab, as we saw before, you can just double click, make it full screen, and really get the most out of looking at this information. You can see how useful it is here to quickly add these comments to our core data and use this as we build up a better understanding of this core archive that we have. Moving on to borehole analysis, you can bring in your FMI logs, your borehole images, and you can view these. You can also interpret here. You can display any dip data that you have brought in from any other software. But if you need to, you can also interpret this as well. And since making this video, this functionality is significantly expanded with colors to make these icons easier to pick. And you'll notice that our rows diagrams, our stair nets update as we're picking this data. All these windows can be synced together so we can see that structural data being picked on the 3D stair nets, on the 1D stair nets, sorry, 2D stair nets, and rows diagrams as we pick it. We can copy and paste from Excel directly into these charts, and we can update this on the fly. Now, that borehole information is also very useful when we're looking at minimum stress, maximum stress, and over the last year and a half, we've really expanded the offering for the geomechanical calculations we have. I think we now have over 40 to 60 geomechanical calculations and variations of these equations within tNav that focuses on specific areas like pressure calculation, elastic properties calculation, and strength property calculation, and more recently looking into wellbore stability calculations as well. You can see the range that have been added, and this is particularly grown due to the interest of understanding geomechanics in CCS projects and geothermal projects. With just a quick summary of kind of what kind of properties we can look at now. So mechanical properties such as your Young modulus, Poisson's ratio, unconfined compressive strength, our tensile strengths. Looking at our stress models, our minimum maximum horizontal stresses. And then when we're looking at our drilling windows, we can calculate in the exact same software as we do our petrophysics, as we do our static modeling or our dynamic modeling, all in one space. We can start to look at our drilling windows, our breakout pressures, mud loss pressures. And then more recently, we now have the ability to view these more circles, these geomechanical diagrams, and you can use either constants or logs as inputs and actually visualize these and use this as a communication tool for understanding when failure may occur. Now, in tNavigator, it's rapidly growing in the petrophysical space. Now, this is an example from my colleagues in Jakarta, Danny and Ivan. So thank you to those two guys. They did a fantastic project looking at how we bring multi-mineral analysis into tNav. And so this was the first approach where you run this multi-mineral analysis via Python because it wasn't quite implemented in tNav at this point. But if we want to do something, Python opens up the doors to really allow you to kind of any calculation, anything workflow you'd like to run can be done with the use of Python. So in the first instance of this, we ran it and we called a web-based browser just to kind of view these results. But then we want to take this into tNav and show the next steps. So just a quick overview of some of the work that these guys did. Now we have our deterministic kind of log analysis. This is just taking one log and calculating an output. But why might we want to use multi-mineral analysis? Well, it can give us more accurate lithology quantification. It allows us, when we're looking at kind of more complex rock mixtures, such as quartz, clay, carbonate systems, that these standard methods might oversimplify it. We're using multi-mineral analysis. It allows us to better understand these mineral proportions and get a more realistic rock description. It can also improve our understanding of porosity and saturation estimates. So by accounting for these differences in densities, these matrix properties, it allows us to reduce the errors in these calculations. So if we correct for clay volume, bound water, and mineral composition, we're going to be able to better define our saturation calculations. So this is just looking at how these equations might look. Of course, we need to define what these constants are. So the constants for quartz, for our clays, for our carbonates, put these variables in at the start. And we'll see that and how that looks in the workflow here. So we define those constants. We're going to gather our data. We need to then create all these equations we just showed on the last page, reconstruct these equations by just typing them into Python. And then we're going to calculate the error and then optimize on these errors. And to do this, we bring in a number of Python libraries, such as NumPy for numerical operations, pandas for data structures, and SciPy for optimization. And we can then display these results and QC them once we've optimized on the error to get the best result. So if we just quickly look through that script there, on the left in that column there, you'll see 1 to 9. These are the steps taken. The first icon there is that blue and yellow Python icon. This is where we've implemented that Python code, thanks to Danny and Ivan. And we'll just go through these steps. And then the rest of those calculations are just standard inbuilt interface options within tNav. So nothing new there. So the first step of this is importing those Python libraries I mentioned. So we can see the functions where we've imported the math, the NumPy, the Panda, then the SciPy for optimizing. Then we go to data loading, where we gather and pre-process this data. And note that these blue lines are the functions that we can call within tNav. Now, this is very useful for those of you aware of kind of Python capabilities. The ability to be able to have all of these references already. And we have hundreds of these references where we can grab a well, or we can grab a depth, or we can grab a horizon. Very simply, already being defined completely reduces the time that if you were just doing this solely in Python, you'd have to assign all these references yourself. So dramatically increases the speed at which these can be built up. The next step here is defining our endpoints, so all the constants for those minerals. And note that this was the initial kind of step, but since then, using Python, you can actually add to an interface. So now your users who are maybe not Python friendly can just input these numbers as a table. So you'll see there in the final kind of result, that's what we look to do. And then finally, we add those equations that we saw, and then we're going to calculate the error. And finally, bringing in that minimize from SciPy, you see at the top there, just in blue, minimize, we'll bring that in just to optimize and minimize that error of the final result. So this is what the result looked like. So in black was our input logs, in red was the output logs. You can see the stacked plots with the mineralogy, and then what we output is that porosity, that V-shale and saturations, and you can see the error on the far right there. So this adds a lot more flexibility by implementing this in Python, which wouldn't have been possible otherwise. And it adds a lot more flexibility than potentially the standard plug-and-play PlayStation approach that you might take in other softwares, where you're filling in numbers, but without being able to kind of see behind the bonnet or see behind that black box to actually see what's happening in the background. It gives you complete flexibility to control and change how the equations and what constants are being used. Now, for those of you who are saying, well, Marcus, I'm not too familiar with Python, this is a bit too much for me, don't worry, I'm in the exact same boat as you guys. And it was only earlier in the year I was calling SciPy Skippy, much to the amusement of my Python colleagues. So for those of you who don't want to get hands-on with Python just yet, if we look at our workflows, we can see this black box at the top. This is our workflow library, where the tNav team have already implemented a bunch of different workflows. And this is where you can find that multi-mineral set of workflow lines there. We just load this into our workflow manager, and all of those calculations, including that unique Python script, is brought across with a description of how it works for you to run it in your own calculations. So Petrophysics doesn't just stop there. In tNav, using Geology Designer, you go on to build grids, to QC these grids, to use all that useful information from our borehole images, maybe fracture intensity, to design and develop our discrete fracture networks to better understand how those units are fractured and how they might flow. We can then take all that information and use all of our well logs and how we've upscaled this to interpolate using trends, attributes, and populate our grids with useful rock and fluid information. And of course, coming back to those initial petrophysics, checking histograms and crossplots to ensure that those distributions are accurate. So I love this slide, and I think it's very important just to highlight the ability to do these things in the same space, whether you're in the field together across different domains, or whether you're in the same software together with different domains. The ability to communicate much more seamlessly and move from seismic to petrophysics, to building your static model and dynamic model, and creating one workflow which creates a history of that asset, which is easy to track back, to see what was done, and then also to repeat and automate, completely changes the speed and the communication that we have within a team. This is what tNav looks like. The functionality that we've been looking at today sits within Geology Designer. This is continuing to grow, but it's completely linked with every other aspect of the tools we have. So whether you're a geophysicist working in seismic, or whether you're a petrophysicist or geologist working in Geology Design to understand and correlate across these wells, bringing your core data, your borehole data, or whether you're an engineer working a model designer, all of these work in the same interface and allow you to seamlessly move through that space. Now, what does that allow? This is all tied together by our workflows. You can have a workflow for each aspect of these different domains, and it allows for limitless automation and the ability to keep track, apply variables to each of these aspects, and opens up the space to understand our uncertainty. Now, in integrated subsurface modeling, petrophysical uncertainty directly influences net to gross scenarios, permeability realizations, saturation height functions, and rock property distributions. And so therefore, petrophysics is key to bringing into this workflow, and hence why we find it so important within tNavigator that this also becomes a key part of our workflows and how we can incorporate it within uncertainty. So here you can see us looking at our petrophysical relationships, looking at some of the Lorentz coefficients, starting to build up an ensemble of models to understand the range of uncertainty we have within a project, looking to see which are the sensitivities and which variables have the highest impact, and then optimizing on this to get the best result and to get the best match with our data. And this is a complete cycle where we can go around and try and improve this as much as possible. As we add new data, it can be completely rerun. So hopefully today I've given you a very brief introduction to where we're growing within petrophysics, the ability to already do a lot with our petrophysical calculations to integrate your core and your borehole data together. Petrophysics is essential to bring that raw data and really calculate those rock and fluid properties which are necessary for understanding our static and our dynamic models. So without this strong petrophysical input, these integrated subsurface models risk being inaccurate or misleading. Siloing your petrophysics just in one software and then not easily being able to take that uncertainty across all those inputs across in one space does lead to possible situations where you've missed some of that information or not fully understood the uncertainty ranges that might occur. And tNavigator offers an integrated platform initially known for Formula One speeds of the simulation, but now better known for this integrated approach, which takes you from your petrophysics, from your seismic interpretations, all the way through to building fast simulation-ready models, and including your facility modeling, your network modeling, to understand the full assets. I've shown you some of the capabilities we have for log calculations. There's a lot more detail we can go into, and if you'd like to get this detail, please feel free to get in contact with us. We'll be more than happy to expand on any of these topics, and if you have specific interest in petrophysics, we'd be delighted to hear from you. We can talk to you more about the roadmap we have, and also hear from you about what are the key tools you'd like to see as we grow in 2026. Thank you all for listening, and I'll be delighted to take any questions and also to get in contact at a later date as well.
Lovely, thank you, Marcus. Those visuals and images in the slides are absolutely beautiful. I'm sure everyone appreciates your honesty and had a little chuckle about your Skippy comment. We have a little bit of time for questions. If anyone wants to pop into the chat box, there are a couple. Next week, Marcus, we just pop back to the last slide quickly. Our next webinar, we're sticking with the geoscience theme, so that's the seismic evolution in tNavigator, which will be presented by our colleague Elias. So that's on Tuesday, 25th of November at the same time. So you can sign up for that on the website, and all the links will be in the follow-up emails as well. Let's have a look if you're ready for some questions, Marcus. Now, you did mention this briefly at the end there, but we've got a question just asking if tNav has the capability for multiple users to work on the same project. So if I make any log edits as a petrophysicist, can I push this to my geologist and reservoir engineer?
Yeah, you can. So we have a tool that connects all of our kind of modules together. First of all, it's just one interface. So anything you do is the exact same code in the background. Everything works seamlessly. We're not trying to tie these things together. And how this all connects is a tool that we have called Teamwork. What this allows you to do is to improve something, edit something in your project, you send it back to the main project, and then the admin, or however you set this up, can then accept that into your project, and you can see, so for example, a couple of geologists work on the same project, you can see new well markers coming in. If you've got new logs that have been calculated, you would see some information showing new logs identified for porosity. Would you like to accept this into your model? And so the users have that ability to accept and bring this back from that master project as it's being kind of updated and stored, and this can be brought across for all of those petrophysical inputs, any kind of new horizons or seismic interpretations that have been used, but also our engineers, any updates to well design or perforations. All this information can be brought across, and everyone can be working on that same project at the same time, working in one singular workflow, which allows for a very quick updating of that asset without having to export and import anything.
Thank you. And just another question about the geomechanical models. So are your geomechanical models fully coupled with the dynamic?
Yeah, so I only very briefly touched on geomechanics there. There is a wealth of geomechanics that's been added over the last few years. And we were looking at 1D geomechanics, but yeah, if you do go on to create these 3D geomechanical properties and you're looking to simulate, then in tNavigator, it's fully coupled, which means that at every single time step, we're calculating geomechanics and the simulation output at the same time. And that's being used to calculate, say, if the porosity changes due to geomechanics, that then has an impact on how that's simulated in your grid. Not all simulators do that, but it's an important thing to be able to do to get more accurate results.
Thank you. Okay, let's do one last question. This is a good one. So, hi, is the Petrophysics module you presented a separate module from seismic and geomodeling, or is it included in the geomodeling package?
Yeah, so everything that we've seen, and we've only seen a little bit today, is completely included within Geology Designer. So everything from your well correlation, from doing your petrophysical logs, from editing those logs, all the way through to building a grid is just in one license. So it's not segmented at all. All these tools are available and very quick and easy to build that grid and go back and compare those petrophysics. So yeah, it's just the one module.
Thank you, Marcus. There's a couple of questions with people just asking for like any follow-up materials or tutorials. So of course we have a lot more information available. So if anyone does have would like some more information, then just reach out to us and Marcus can share some details with you. Okay, cool. I think we can wrap it up there, Marcus.
Okay, thank you very much, everyone.
Yeah, thank you for joining. And yeah, if you'd like to join the session next week, then please do sign up. Cool. Thank you very much and have a nice day.
Bye for now.